Take a look at the Bahamian coastline. From the surface, these crystal-clear waters look like a perfect, untouched sanctuary, isolated from the noise and waste of modern cities. But scientists recently ran a study in the waters around Eleuthera Island that challenged that assumption. Researchers drew blood samples from 85 wild sharks, spanning 5 different species, to see exactly what was circulating inside these apex predators. Approximately 1/3 of these predators tested positive for synthetic, human-made drugs. Finding our medicine in the blood of wild marine animals shatters a comforting illusion. It proves that no part of the ocean, no matter how remote or pristine it appears, is truly isolated from human activity on land. The researchers weren't finding obscure industrial chemicals. They found traces of our everyday routines: caffeine, cocaine, and common household painkillers like acetaminophen and diclofenac. This graphic breaks down the exact test results. Out of the 85 wild sharks sampled, 28 carried these substances. While cocaine has been detected in marine predators off the coast of Brazil, this marks the very first time caffeine and acetaminophen have ever been found in any shark species anywhere in the world. These drugs are affecting the animals. Blood tests revealed distinct changes in the shark's metabolic markers. The infected predators showed altered levels of triglycerides, which are fats, alongside elevated indicators of stress like lactate. Pharmaceutical waste is currently altering the internal biology of animals at the top of the food chain. While floating plastic is easy to see, microscopic contaminants of emerging concern are slipping past our environmental defenses. These invisible chemicals originate from our daily water usage. Coastal areas like the Bahamas are experiencing booming local populations and massive, sprawling tourist resorts, which create enormous daily demands on plumbing. Every time someone takes a shower or uses the sink, that water flows into local wastewater systems. But those systems easily become overwhelmed by the sheer volume and complex chemical makeup of the effluent, failing to filter out microscopic medicinal compounds. Then there's runoff. When heavy rain hits the island, it washes directly over roads, farms, and cities, picking up surface oils, fertilizers, and discarded chemicals, and carries them straight into local waterways. Rapid coastal development, combined with inadequate filtration infrastructure, has built a direct, invisible pipeline. It runs straight from human bathroom sinks into the open ocean. This diagram illustrates a marine food web pyramid to help explain the hidden engine driving this massive chemical transfer. Scientists call this process bioaccumulation. It starts at the very bottom. Microscopic marine life absorbs highly diluted, trace amounts of these chemicals directly from the contaminated water around them. As mid-level fish eat thousands of these smaller organisms over time, they absorb all of those trace chemicals. Because their bodies cannot process the synthetic compounds, the drugs are stored and packed tightly into their tissues. Finally, an apex predator, like a shark, eats those mid-level fish. Instead of a diluted drop, the shark ingests a concentrated dose of human chemicals in a single meal. The vastness of the ocean fails to safely dilute our pollution. Instead, the marine food web acts as a biological magnifying glass, concentrating our waste directly into top predators. We have a psychological habit of believing washing something down a drain makes it go away, but the water cycle guarantees that nothing is truly erased from the planet. To solve this, you might hear proposals suggesting we build massive, expensive underwater filters to continuously scrub the ocean clean. But trying to filter the open ocean without addressing the source is like emptying a flooding bathtub with a tiny spoon, ignoring the running faucet. Engineering massive end-of-pipe technologies is useless against a continuous systemic leak pouring out of human civilization. The only scientifically sound approach is source reduction. We have to stop the pollution before it ever has a chance to enter the wastewater infrastructure. That requires changes in our daily consumption. We need to sharply reduce single-use items and commit to safely disposing of chemical cleaners and expired medicines, rather than dumping them down the drain. We also need to monitor our overall water usage. Taking shorter showers and turning off the tap reduces the sheer volume of water flooding our local treatment plants, giving those systems a chance to filter out contaminants. We cannot isolate the ocean from the consequences of our lifestyle. To protect the wildest, most remote predators on Earth, we have to start by changing the mundane, daily habits inside our own homes.